In this video tutorial, we'll be creating a model using Crtiterium Decision Plus from InfoHarvest to access the tactical priorities for restoration actions for each of the subwatersheds in the Chuacan watershed area. The Chuacan watershed is located in the Fremont National Forest in south central Oregon. This model will be used in the first step of this EMDS tutorial. Since the early 19th century, a variety of issues caused disruptions to the natural ecosystem of the area. This includes changes in the beaver population, water quality, and downcutting. The Forest Service and Fish and Wildlife Service needed to evaluate the Upper Chuacan watershed in multiple scales using EMDS. The CDP engine is leveraged by EMDS to perform this analysis. In this tutorial will be a step-by-step explanation of how to create this model in Crtiterium Decision Plus. Crtiterium Decision Plus leverages multi-criteria decision analysis to logically allow you to work through making the best decision based upon the available information and understanding its underlying issues. Please note that if you haven't downloaded Crtiterium Decision Plus, you can download it from their website at http://www.infoharvest.com and download an evaluation copy from the download page. Tutorial step by step. Click on Model menu. Select Generate Hierarchy, and a dialog box appears to enter the model name and notes. Type in EMDS Watershed Tutorial and then click OK. There are two levels displayed by default, the goal level and the alternatives. There's only a single goal that is allowed per CDP model. Alternatives are a set of options which you either wish to prioritize or choose the best alternate form. With EMDS, alternatives are usually the individual features that are being evaluated. So for this case, there is no need to create individual alternatives. However, there are cases where there may be only a couple of alternatives, and you can perform this evaluation quickly with the CDP environment. Click the goal entry under the goal level. Click Edit Name/Notes. Give the name of the goal to be Restoration Priority and click OK. Notice that the name is cut off, but you can resize a level by going up to the level names at the top of the screen and clicking on the border between the names and dragging them to resize it. Our approach to building this model is from the top down, which means that we're going from our goal and breaking down into one or more hierarchical levels. The factors will allow you to make an informed choice. You can do a bottom-up approach where you start with the data and move towards the goal. In our case, it makes sense to utilize the top-down method. The next step is to create a level between the goal and the alternative. Click on the Alternative Levels title at the top of the page. Click on Level and choose Insert Level. The new level will be created between the goal level and the alternatives level, but has no title. For this tutorial, we will give the level the name of Level 2. Click on the empty title and type in Level 2. There will be 5 criteria in this level: efficiency, feasibility, WS condition, reach condition, and stream access. Criteria can be linked to both other criteria on other levels and directly to the database. The first 2 criteria above are regular criteria. We need to create each of these criteria. To begin, there is currently a single criteria listed called Name 0. Right-click on it and select Edit Name/Notes. Give it the name Efficacy and click OK. Double-click on the efficiency item so that a property window is brought up. This dialog allows you to set the scale for the criteria, assign weights, create rules, and uncertainty information. For our needs, we will need to create a scale for the alternative and give it weight. Click on the Assign Scale. The Assign Scale dialog appears. Click on the New button. This will give you the unit name preferences. The best value will be 9 and the worst value will be 1. Click OK and then close. You should be back to Priority dialog box. Click Close. To add the next criteria, we need to right-click on Efficiency and select Insert Block Below. This will create a new criteria item and type in Feasibility. Before setting the priorities of the criteria, we must connect it to the lower criteria or alternative. Click and hold on Feasibility criteria and drag it to Alternative 1. A line will appear to connect Feasibility to Alternative 1. It will be the same type of appearance as Efficiency connected to Alternative 1. Double-click on Feasibility. Click on Assign Scale. Select the same scale as created for Efficiency, which is Preferences from the drop-down list. Click OK to continue. Right-click on Feasibility and select Insert Block Below. Give this criteria name WS Condition. Then attach this new criteria to Alternative 1 by dragging the new criteria to it. WS Condition and the remaining criteria in this level are known as least criteria, in that this criteria is mapped to an actual database field. Double-click on WS Condition and click Assign Scales. In this case, we need to make a scale range for NetWeaver values. All inputs from NetWeaver model is a range of -1 to 1. Click New. Give the name as NetWeaver Metric. For best value, enter 1. For worst value, enter -1. Click Close and then OK. Right-click on WS Condition and select Insert Block Below. Give this criteria name of Reach Condition. Then attach the new criteria to Alternative 1 by dragging the new criteria to it. Double-click on Reach Condition and click Assign Scales. Select NetWeaver Metric. Right-click on Reach Condition and select Insert Block Below. Give this criteria the name Stream Access. Then attach this new criteria to Alternative 1 by dragging it to the new criteria. Double-click on Stream Access and click Assign Scales. Select NetWeaver Matrix. To connect this level to the goal level, click and drag the Restoration Priority item on the goal level and drag it to the Efficiency item on level 2. Perform the same drag operation to connect the 4 other criteria on level 2 to the goal. Your model should appear as the following. We have 2 criteria on level 2 that still need to be linked to external data. Remember, the rule is that every criteria must eventually be fed by a lowest criteria, which is how we connect it eventually to the data inside EMDS. This means we need to add another level. Click on Alternatives at the top of the last column. Click on the Level menu and select Insert Level. Click OK at the dialog box. Give this new level the name of Level 3 by clicking on the empty label at the top of the screen. We have 5 lowest criteria we need to add: Serial openings, water temp, canopy density, row density, and culverts. Give it the name serial openings. Double-click on serial openings and click Assign Scales. In this case, we are looking for the percentage of serial openings. Click New. Give the name as % serial openings. For the best value, enter 15, and for the worst value, enter 30. Click Close, then OK. Right-click on serial openings and click the Insert node below. A new node will appear. Give it the name Water Temp. Then attach the new criteria to alternative 1 by dragging the new criteria to it. Double-click on Water Temp and then click Assign Scales. In this case, we are looking for water temperature range. Click New. Give the name as degrees Fahrenheit. For the best value, enter 64, and for the worst value, enter 75. Then click Close and then OK. Right-click on Water Temp and click the Insert node below. The new node will appear. Give the name Canopy Density. Then attach the new criteria to alternative 1 by dragging the new criteria to it. Double-click on Canopy Density and click Assign Scales. In this case, we're looking for the % density of the tree canopy. Click New. Give the name as % canopy density. For the best value, enter 100, and for the worst value, enter 50. Click Close and then OK. Then attach the new criteria to alternative 1 by dragging the new criteria to it. Double-click Road Density and click Assign Scales. In this case, we are looking for the density of the roads per square mile. Click New. Give it the name RD, miles per SQ mile. For best value, enter 1.60, and for the worst value, enter 4.70. Click Close, then OK. Right-click on Road Density and click Insert node below. Give it the name Culverts. Then attach the new criteria to alternative 1 by dragging the new criteria to it. Double-click on Culvert and click Assign Scales. In this case, we are looking for the number of culverts for each sub-watershed. Click New. Give the name as number of culverts. For the best value, enter 1, and for the worst value, enter 5. Click Close and then OK. Our final step is to assign the relative weights of subcriterion for the criteria. For efficiency, we have the subcriterion of serial openings and water temp. This particular criteria uses the pairwise method, where subcriterion is subjectively compared to each of the other on the same level. To implement this, we need to double-click on Efficiency. Select the Method menu and click on Full Pairwise. In this case, the subcriteria on the left should be water temp, and the subcriteria listed on the right should be serial openings. If they are reversed, click on the arrows next to the name on the right side of the dialog, and they will switch names. Click OK and continue. Double-click on Feasibility, which uses the default direct method. Set road density to 5 under the weight box, set culverts to 3, and road density to 3, and then click OK. Save this file by clicking on the File menu and give this file the name chews_tutorial. Tutorial step by step. Click on Model menu. Select Generate Hierarchy, and a dialog box appears to enter the model name and notes. Type in EMDS Watershed Tutorial for the name, and then click OK.